Today we are going to be learning about pulleys. This is in section 1.1.1. A pulley is very similar to a lever in that it is a wheel with grooves in it with a string attached to it, and it can cause a mechanical advantage to be exerted, or it can just change the direction. There are first two different types of pulleys. The first kind are fixed pulleys. They are fixed in place. They're attached to something, such as the ceiling. This will only change the direction of the direction of the force. The second kind are movable pulleys. This is where you will actually experience a mechanical advantage. So what we're going to do is we're going to shift over to an actual real pulley systems. So here are three different pulley systems I have set up. The first one is the first non-movable fixed pulley. If I pull down on this string, this 500-gram weight moves up, but I have to pull down exactly the same amount of weight this is. This has no mechanical advantage. It's a mechanical advantage of 1. Contrary to this one, which has it's a movable pulley, the pulley moves up. At this point, this has a mechanical advantage. And how we calculate mechanical advantage is the number of strings that go opposite to the travel. In this case, this one is moving up, and we only count, there's 2 strings, but this one's going down, so we only count this one. So there's only 1 string. Contrary, this one it's going up, and there's 2 strings that are going up, so that means you count these 2. We go to our third and final one, where we can combine fixed and non-fixed pulleys, and they're going to create what we call a block and tackle system, where you have multiple fixed pulleys and multiple movable pulleys. Again, we count how many strings there are. 1, 2, 3, 4, 5. And then we look at the direction of travel. It's moving up, and the only one that's moving down is this one. So we don't count this guy. So we count 1, 2, 3, and 4. This has a mechanical advantage of 4. So block and tackle systems are used in several cases, such as in engine lifts. Going back to the PowerPoint, we can look here at somebody trying to lift up their motorcycle. Again, we can look at the drawing here. We have mechanical advantage is equal, or the IMA is equal to the number of strands opposing the force of the load. Easier way is this one's going up, so this string's going down, so you just add them all up and subtract 1. So it's 1, 2, 3, 4, 5 strings minus 1 because this is going down opposing the travel. So this has a mechanical advantage of 4. Now we can also do this with compound machines. If you notice, here we have a pulley and a lever arm. So what we need to do is calculate the total ideal mechanical advantage total by multiplying the pulley and the lever. So first, calculate the pulley's mechanical advantage, followed by the lever's mechanical advantage. Okay, in this case, you count the number of strands, 1 and 2. Again, noticing that this is going up, and both strings are going up, so that means you count both of these strings. So its mechanical advantage is 2. The lever arm is 12 over 4, so that gives me 3. So 2 times 3, so a total of mechanical advantage of 6. With separate ropes or cables, you can then combine them into a much more compound machine. So in this case, this is a compound machine. You have 1 and 2, another 1 and 2, and another 1 and 2. So this case, it's a compound machine with several pulleys, and it is 2, 2, and 2, totaling up a total of mechanical advantage of 8. So it's 8 times as less. And we can look at here, you got 80 pounds down, but 10 pounds pulling up. So, and 1/8 of that total. The AMA, again, you just look at how much pounds you're pulling down compared to the weight that it resists. So you just take your 800, divide by your 230, which gives you 3.48. What is then the efficiency? So rewind the video and look at the efficiency of this system. Efficiency is AMA, which we already calculated as 2.48, IMA, which we already calculated as 4, so 2.48 divided by 4 times 100, 87% efficient. Now, some common misconceptions. Angles don't matter. That is false. Angles do matter, but in this class we always will go straight up and down. We will never do angles. Angles requires trigonometry, and we're not going to deal with that. Another misconception is the effort strands that are pulling up. Not necessarily true. In this case, we are pulling something down with 800 forces, and you have these two. Again, you look at the opposing direction, opposing over the travel. So this is pulling something downward. So you got 1 and 2 strings pulling downward. So the mechanical advantage of 2. Again, if you have any further questions, please ask your teacher.